Laura.
No problem.
So point number 1 in the agenda, this webinar is being recorded and it will be made available on the NMIS YouTube channel, and later down the line we will also be hosting this on a dedicated web space particular to this project. So everyone's microphones and webcams have been turned off during the main session to avoid any background noise. You can type any questions throughout the session in the chat tool. I would say keep these questions to the AMBATS project and we'll collate them and answer them at the end. And we've got the network breakout rooms for you to ask any questions direct to the speakers today. So as I said, there'll be some time at the end to go through your questions, and we've also got the dedicated breakout rooms this time. If you are wanting to use the hashtag NMIS Insights, we'll be able to pick up any questions there on our Twitter. We'll also be issuing a survey after this, so we'd appreciate if you could take some time to fill out that survey after the webinar. That'd be fantastic. So today's webinar hosts, you have Stephen Fitzpatrick, who is the Additive Manufacturing and Machining Team Lead at NMIS, and also the Principal Investigator of the AMBATS project. And myself, Grant Payne, I'm a manufacturing engineer in Stephen's team, and I'm also the project lead on this project. Just quickly go through the agenda for today. So we'll do a quick introduction to the AMBATS project. Stephen will then give us an overview of the technology we have at NMIS, and then we'll hear from Ian Gibson at SEED to talk about the cluster building activity that they're doing in parallel with this project. Following on from there, we'll have a quick comfort break to allow you to grab a coffee, and then when we return, we'll be looking at the Scottish additive manufacturing sector. Then we have tech talks from Gregory Campbell of CA Models, Andy Simpson of Angus 3D Solutions, Nell McVeigh and Dickon from AMMA 3D, and those last three will form the hosts for our breakout rooms where you can discuss directly with them. So looking at some particulars to do with the project, it is a European Union ERDF funded project, and it is moderated by Scottish Enterprise. The lead research institution on this is University of Strathclyde, but more specifically so, National Manufacturing Institute Scotland, NMIS. As I've said, Stephen is the principal investigator and I am the project lead on this, and the project will be running until December 2022. So this makes up part of the awareness events that we're doing through a series of webinars. I would like to begin by thanking those who have supported the project up to this point and will be continuing to support the project as we move forward. So top line there are the people presenting today, but we also have RAM Engineering in Forfar, Kutry in Glasgow, Renewable Parts who are split between Argyll and a site in Glasgow, and Lamond and Murray in Fife. There's also a bigger network of support behind this project, in that we have the Highlands and Islands Enterprise, which makes up these local council boards in the Highlands and Islands. We also have the Glasgow City region backing this project. That's made up of Glasgow, North Lanarkshire, South East Renfrewshire, Inverclyde, West Dunbartonshire and East Dunbartonshire. And lastly, we have Fife Council, who also supported this. But this project is working across Scotland, so if you are in a council that hasn't been mentioned here, don't worry, these are just the people who pledge support towards the project. There are contact details here for the people who lead this. So we have Jackie Hill from the Glasgow City region, Anne Camus and Sandra Robb from Fife Council, and John Mackenzie from Highlands and Islands Enterprise. So, good afternoon to all of the business development team who've managed to join us today on this, and Fesker Ma to those who are in the Western Isles. And what we've actually done here is done a Gaelic translation of additive manufacturing and the project Additive Manufacturing Business and Technology Support for those of you who speak Gaelic or are going through lockdown and keeping yourself entertained with a wee bit of Duolingo. We also have industry and innovation support networks such as SMAS. So we have Tom Gillespie and Ian Collison. Scottish Engineering, Julie Wright and John Campbell. In SEED, we've got Ian Gibson, who will be speaking later on. And lastly, Dr. Abigail Hurd from KTN, so the Knowledge Transfer Network. So as I said, this is the first in series of what is going to be a 9-part series of webinars. But the first one you know about today, looking at Scottish supply and additive manufacturing network. The next one will be taking a deeper dive into some of the technologies that we have at NMIS. So we've invited Renishaw, who will be talking about powder bed, metal powder bed solutions, and also Stratasys, who do a range of different polymer AM processes. And the third one, before the end of the year, will be focusing in on hybrid manufacturing technologies. And on that, we have Hybrid Manufacturing Technologies, the company themselves, as well as RAM Engineering and DMG Mori, who have their own hybrid manufacturing solutions. So the National Manufacturing Institute Scotland is organised and run by a One Scotland team. So it's operated by the University of Strathclyde in Glasgow, but we also have a support team behind us, the Scottish Government, Scottish Enterprise, Highlands and Islands Enterprise, the Catapult Network, Skills Development Scotland, Renfrewshire Council, and lastly, the Scottish Funding Council. So the High Value Manufacturing Catapult Network is a network of research centres across the UK. So we have ourselves, the Advanced Forming Research Centre, which it makes up part of the National Manufacturing Institute Scotland, located in Glasgow. And then the other 6 centres, all of which have different specialities spread across England. So for this project, there's some key criteria that you need to meet to be able to get support free of charge, I might add as well. First of which is you're located in Scotland, you're a small to medium enterprise, and also adherence to horizontal themes. More information can be found out about this at the following web address. So now to actually look at what we're trying to achieve with this project. And it's really all about providing Scottish SMEs with the knowledge required to make the correct business, technology and investment decisions in additive manufacturing. So we'll be doing this by de-risking innovation, supporting the adoption of additive manufacturing, and growing that Scottish supply chain. So through engagement and support from us, we'll be able to provide the SMEs with confidence to invest in new additive processes and adopt new technologies into their business. So we've identified that there are barriers to adopting additive manufacturing, and some of them are listed here. And this is such as suitability, so understanding which process or processes match your engineering challenge. Controlling variability, so how do you gain repeatable results in what you're doing? Reliability, so how do you gain conformance in your sector? So this is now starting to think about mechanical testing. And then lastly, scalability, so how do you meet not only your current demands, but also look to the future to be able to meet that demand as well. So additive manufacturing is a complex set of technologies, and each provide unique integration challenges within them, within an engineering environment. So some of these are that you need to have that in-depth knowledge required to make effective technology investments. The expertise and process understanding we've identified are crucial to being competitive. Understanding the complex supply chain, again, is going to be essential to being financially sustainable. And lastly, advanced facility designs is one of these key things that will gain you adherence to all the numerous health and safety guidelines that are out there. And by looking at this early on, this is how you can trigger business efficiencies further down the line without having to come back and change what you've done. So by working with us, in this project, what we can really do is move towards this work smarter, not harder approach, which we've identified as being imperative to success. So what we've done is we've broken this down into a number of support packages. And I would say these are example support packages, and especially the content within them. Because what we'll do is we'll work with you to understand what is it that you need. This is not just a prescriptive, you must follow these. We'll really tune it to what your business needs. So these are things like the awareness events that we're doing today. These are originally planned to be face-to-face events, but we've moved quickly to realign them to the current situation. But it may be the case that you're just looking to pick one or two of these things and align them to your business. However, we understand that people may wish to be taken through an end-to-end journey on this. So ranging all the way from understanding product suitability right the way to the end towards approval, where you can look at certification, qualification, all these sorts of things. So we're looking pan-sector and pan-Scotland on this project. We've done some work to identify what sectors we think would benefit from additive manufacturing, but this is, again, not a prescriptive list. If you work within a sector that's not been represented here, please do just let us know, and we will update this for you. So if we take a smaller dive into looking at, well, how do you develop these business cases to take things forward? Because as you'll know, within industry, anytime you wish to do something new, there has to be a business case behind why do you do that. So if we look at that initial suitability level, the support packages that come within that are the product suitability for AM, design for additive manufacturing, and process selection. But if you look down into more detail about the steps that we take as we go along, what we'll do is we'll look at the information behind that through a workbook that you can develop. And we'll be able to quickly at that first stage, but in detail, tell you which additive manufacturing processes are suitable and should you proceed forward. So on the presumption that at least one additive manufacturing process has been identified as being suitable for your application, we'll then ask you to look at completing a component design specification, where we ask you more questions, then move on to design for additive, process selection, and now that we're down to a single manufacturing process, looking at design for manufacture. And that's how we build up a business case. So how this works is you'll submit an inquiry to us, and the first port of call is looking at that in terms of its suitability. So we'll ask you questions and ask you to provide a geometry for us to consider, certification and documentation considerations, manufacturing considerations, functional considerations, and lastly, commercial considerations. And these are all brought into the suitability. Coming out of this, the next stage is the component design specification, and that previous exercise we will compile into a report. That report is brought through into this section, so you don't need to fill things out again. We'll use the information you've already provided, but now we'll start to look at more details such as safety and go into more detail of the themes that we'd previously discussed, and they're brought into that. So now that we move through into the design for additive manufacturing stage, we can bring in the suitability report and the component design specification, so we have details of how we're going to go about this next stage. So here we'll be able to run through all the different softwares that are out there and tell you the different functions that they have. We've then created a matrix that will allow you to input what your business does, and this will shortlist these technologies into smaller form. And then we'll do a quick demonstration to show you how the software works, and then start to work on your actual geometry that you've provided to us and do some optimization work on that. Coming out of that, with consideration of the different technologies that we've shortlisted, we'll generate some concepts in them, and that they all come into the output of that, which is the design for additive manufacturing report. So all this information is then fed through into how we begin to select a single process. So we'll go into a wee bit more detail here, where we'll discuss with you about some of the skills that you have within your business existingly, consider the manufacturing post-processing for these different concepts that we've generated, how they would perhaps fit within a supply chain. And then lastly, all this information is put into a process selection matrix, and we'll end up with one manufacturing technology that we'll take forward for consideration. Excuse me, and it's at this point that we go to a more traditional design for manufacture. So all this information that we've generated up to this point is brought into here. And now we can really focus in more detail about the material and process standards for what we've selected. And we'll go into more detail looking at the manufacturing post-processing. And then we'll begin to do a detailed optimization really specific to the manufacturing process we've selected. And again, looking more detail of how this fits into a supply chain. And lastly, creating a manufacturing plan. And that finishes off that section. And this is what leads us up to our business case. So all the information is brought through into that. And now we look to do a risk review matrix, and then with consideration of technology adoption, we do a manufacturing review, a financial review, and also a strategic review. So this is entirely bespoke to your business. I'm now going to hand over to Stephen, who's going to discuss our technologies that we have at NMIS. And Stephen, if you can start speaking, brilliant. If not, I might need to try and find you and unmute you.
I'm okay, Grant. Can you hear me okay?
Yes, excellent. I'm going to put myself on mute, and I'm going to now hand over.
Okay, guys, good afternoon. My name's Stephen Fitzpatrick, and I lead on the Additive Manufacturing and Machining Group at NMIS. And we have, a diverse group on the webinar today. So what I just want to start off with is going over some unique advantages of additive manufacturing. So obviously it offers, design freedoms. You'll be able to create geometries which aren't possible through traditional manufacturing techniques. Novel tooling and fixturing. There's a big application around conformal cooling, for instance. Part consolidation, where we can bring 4 or 5 components together and actually consolidate them within one design. Rapid prototyping and customization, this is where it's been used, for 20 to 30 years. However, it's making its way into more consumer goods and products. Improved performance through things like, heat exchangers we've seen making their way onto the market through, clever topology optimization techniques. And also high integrity sectors. So, technologies which we'll discuss as we progress in this presentation, particularly around the directed energy deposition, where, you can build 3D geometries and metallic components to reduce lead time considerably. So again, just following the ASTM convention, there's 7 processes as defined by ASTM: fat polymerization, material jetting, material extrusion, binder jetting, powder bed fusion, sheet lamination, and directed energy deposition. At NMIS, we are focusing on 4 of these: material jetting, material extrusion, powder bed fusion, and directed energy deposition. All have their application with specific advantages and disadvantages. Some are polymer-based, some are metallic-based, some have size constraints and constraints on some of the design freedoms that they have, but they all have their use. And I think it's important to remember that, there are only other manufacturing processes available. So they do have their application, but, it's not a panacea and can be used for anything. So within NMIS, when we look at the metallic processes we have, we've got a hybrid LMD system, and we're bringing online a powder bed fusion system and our 2-wire arc systems. And if we look at polymer, as I'll discuss a little bit about the industrial FDM that we have and PolyJet, and we also have quite a few of our desktop FDMs as well. So I'll begin discussing directed energy deposition for the next couple of technologies. And this is our LMD hybrid platform. It is a laser metal deposition machine, but we can also carry out machining on it as well. So powder is blown through the nozzle, and using a laser as an energy source, we can create a melt pool. And it does have some specific benefits over, say, the arc-based processes that I'm going to discuss in a little minute. It's got relatively low heat input. You can get benefits such as lower dilution, faster cooling rates, which give you a finer microstructure and lower thermal distortions. It's also quite an accurate process, so you can get close to net shape, so near net shape components from this. However, the deposition rates are lower than arc-based processes, and also powders bring some challenges with them as well. So this is a process that we've been working on for around 6 years, and we've carried out a number of projects in this application area. And you can see on the left-hand video there, that's a project called Digital. It was a £1.2 million Innovate UK project where we created closed-loop systems for a digital die remanufacturing process. So through LMD, adaptive machining, scanning metrology, and digital integration. And then on the right-hand side there, where this technology can be used to its advantage, is through adding features onto components, particularly things like forged or formed components, to add additional value. So the system that we have is around, it's got a 1.5 kilowatt laser on it, 1 and 2 millimeter spot sizes, and we can have capacity up to around 2 meters in length. And as you can see in the bottom left-hand corner there, we'll be discussing more about LMD and the hybrid platforms in the following webinar series 3, which will be in a few weeks' time. Moving on to our other directed energy deposition capability, so wire arc additive manufacturing. And this is a gas metal arc cell. And one of the unique benefits of this is that it is inert, so we can fill the chamber full of argon and create an inert atmosphere. So materials that are susceptible to oxidization, for instance, we can start to carry out development work on them, and that will give us capacity up to about a meter-sized components. Moving on to the next wire arc system, and this has been installed just now. This is a big install, and this has been introduced through an Innovate UK project called RoboWAM, which some of you may have heard of. And that's in collaboration with Cranfield University, Cooker Robotics, Technip FMC, Airbus Defence and Space. And this is trying to commercialise the WAM process. And again, some of the unique capabilities in this, and you can see on the right-hand side, we have a second robot over and above the deposition robot. And that is for phased array ultrasonic, which we have significant expertise within the university. So this is a plasma arc system. It's Cooker robots that are on that, and we're also looking at component sizes up to about 2.5 meters. So, as I've mentioned, we've spoken quite a lot about the directed energy deposition technologies, and that's been quite aligned to our strategy for AFRC. But when you look at the Scottish manufacturing landscape, there's definitely a need for us to broaden our horizons, because there's a lot of sectors and commodity types that just wouldn't be covered with some of the directed energy deposition techniques that we have. So hence the reason why we've invested in further AM technologies. And the first one is around metallic powder bed fusion. So although there is a number of metal powder bed fusion systems within the UK and the Catapult network, we do need regional capability to support Scottish manufacturing. And these are 2 Renishaw systems that we're bringing in. They are single laser systems. But what we wanted to have is more flexibility to change in and out different materials, so that we could work with a number of different organisations and sectors and different alloy groups. So we've sacrificed a little bit on speed with flexibility. And as you can see, there is a webinar where we discuss more around powder bed fusion, which is happening in November, the 10th of November. And large scale FDM is something that we brought in pretty recently, and this is a Stratasys 900 machine. Again, we've got a wide range of materials that we can support through this. All of the materials are opened up. You do have to pay for the materials, but we have opened up all the materials. And that's where we'll cover, thermoplastics, high performance polymers, and even things like chopped carbon fibre. So in terms of the application areas for this, things like large tooling, jigs and fixtures, prototyping, and even production parts. And I think one of the things that we're starting to introduce just now into the machine is the aircraft interior certification solution, and that's through Ultim 9085. So we're going through a bit of a certification process just now to try and bring the machine up to the standard required for that. And again, there'll be another webinar series to discuss these technologies in a little bit more detail. And finally, just on the PolyJet system, again, it's a Stratasys machine, it's 850. But what this does is it opens up, a lot of different design possibilities, particularly things in full colour, textures, colour gradients, opaques, clears. It does open up a range of opportunities for designers and product designers. So we can create, prototypes, concept models, but there is also a lot of engineering applications for this technology as well. And that's pretty much it from me, guys. I think we have a comfort break before we return, and Grant continues his presentation.
Oh, sorry, I jumped the gun a little bit there. We're actually going to move across to Ian Gibson from SEED, who is going to give us an overview of the AMCF cluster building activity. And Jane is going to share screen on behalf of Ian, and Ian is going to talk. Ian, is your microphone working all right for you?
Hopefully it is, Grant, yeah.
Yep, hearing you loud and clear. So I'm just going to go into mute and allow you guys to present.
Okay, thanks a lot, Grant. Good afternoon, everybody. And first and foremost, hope we're all safe and well in these strange conditions. So as Grant said, my name is Ian Gibson and I'm the Cluster Builder Programme Lead for SEED. But before I go on to talk about SEED and our role, I think it's really important to give everybody an overview of the Advancing Manufacturing Challenge Fund projects. Jane, if you wouldn't mind. Thanks, Jane. So there are 12 AMCF projects, including the AMBATS one, which we're here today. But really the overall aim for all the projects is to have a significant impact on advancing the manufacturing capabilities of small, medium enterprises in Scotland. As you can imagine, the 12 projects cover a range of sectors and applications. So for example, from aerospace to medical devices, from robotics to energy storage and conversion. The projects will look to stimulate SME demand through connection processes, including information sharing and events like this one today, and one-to-one engagement. And I guess, as you can also imagine, there's 12 projects there. There are currently different stages of development, with some already operational and others gearing up to open next year. Some of that is actually, obviously, as I'm sure you can imagine, due to the impact that COVID has had. Thanks, Jane. And that kind of leads us nicely into SEED, the Centre for Engineering, Education and Development. SEED is a not-for-profit mutual assist membership organisation. And basically what we do is we essentially bring businesses, industry and academia together for a mutual exchange of knowledge, experience and expertise. Thereby what we're looking to do is create tangible improvements to business operations. Honestly, if I was to put it simply, what our day job really is, it's cluster building. So I don't think it's any surprise we're kind of doing this role. We were doing the cluster building before the AMCF projects, and we'll actually continue to do cluster building the AMCF projects. At SEED, we also run our own business management and people development program. It's kind of like a mini MBA, I guess. It's called Growth 500. It's been running for over 5 years with a great deal of success. In fact, over 500 companies and 1,000 individuals participating in the program to date. I think one of the big messages that we like to see at SEED is that rather than kind of crowdfunding, we like to promote kind of that crowd learning element where we're kind of learning from each other. Thanks, Jane. So our role at SEED and within the AMCF project is really to kind of sit between Scottish enterprise and the projects. And this is really to help support the projects where we can. And one of the things we want to do is try and link the entire process together. Now we'll do that through partnering the 12 projects. So again, like today, we're with the AMBAT guys, but we're trying to be there for every event we can, supporting, but also looking to leverage project collaborations. So, you know, there might be collaborations that Grant and his team can have with 2, 3, maybe even more of the other projects. Can we help make those connections? As well as using our experience and a large network that SEED have built up over the many years to actually help support the projects. But also, in addition to the 12 events being run by the actual individual projects, SEED also continues to run our own events and complementary activities in parallel. Because as I said, we still cluster build as our day job. This will only serve to help increase the reach and sustainable impact. And in fact, I think we were doing some numbers recently, and since lockdown, I think we've run something like 80 events since lockdown happened. So we haven't just been sitting about and waiting, we've actually been doing stuff. And ultimately, I think it's those three boxes at the bottom that's really important to us about SEED, about what we really want to bring. Because really we want to learn from each other, so that crowd learning thing. But then that's only one part. So the next part is about how do we act and implement these learnings? And then by doing so, we'll actually create impact for the significant change that is actually the ultimate goal that we all want to achieve. Last slide, thanks, Jane. So on the last slide, if you'd like to find out more about the AMCF projects, or indeed SEED, you can see my email details on the slide and our website, which is seed-scotland.com. Thanks, everyone, and back to you, Grant.
Excellent. Thank you very much for that, Ian. So what we'll do now is we'll have a short coffee break before we move on to the tech talks from some of the companies. So feel free to leave for 5 minutes. I wouldn't log off, however, though, and rejoin us at 1:45, I would say. Thank you. Recording now. My clock is showing me that that's 45. So that would be great. Thank you very much. So what I'll do is I'll just skip through here to looking at the Scottish additive manufacturing landscape. This was some work that we did at the very beginning of the project when it was overlapping with the COVID pandemic, or at least the height of it, where we were looking at who within Scotland had additive manufacturing capabilities that would have been able to assist. So there's companies on here that are presenting today, and there's other companies listed on this network that are not here today. So this is a mixture of companies, organizations, and universities that either research additive manufacturing, use additive manufacturing, or do additive manufacturing. But what you will see comparatively to other places, such as the Midlands in England, or places like Germany, our supply chain is quite limited. Now, that doesn't necessarily mean that there's too few companies. It's more a reflection of how much our actual output is in comparison to them. So this is obviously one of the main goals of what we're trying to do in this project, is really boost the supply chain output. And that's encouraging both the existing supply chain and looking for new supply chain growth as well. So as we move forward in manufacturing in a global sense, it is perhaps damaging that the limited supply chain isn't there to meet the global demand. So what we've identified, that investment and growth will be key to success as we come out of lockdown. So as demand picks back up, the anticipation that demand will have shifted slightly. People have taken this time to realign what they're doing as businesses, and we're seeing a bigger push towards additive manufacturing. So we want to be ready to meet that anticipated demand. There may be companies, organizations, etc. on here that we haven't listed. If you do work with additive manufacturing and you want to be included in this landscape, please do just let us know. We're obviously trying to do work to help you. So if we don't know about you, we can't help you, is perhaps what I'm trying to put across at this moment in time. So what we will do now, though, is look to some of the supply chain businesses out there, and they're going to provide us with tech talks about what they do as a business just now, and perhaps where they see themselves going in the future. So we're going to have tech talks from Gregory Campbell, the Operations Director of CA Models, Andy Simpson, the Founding Director of Angus 3D Solutions, and Niall and Dickon from AMA 3D in Glasgow, who are the directors of that company. So I'm now going to ask Gregory to share his screen. So I'm going to stop sharing mine and stop sharing here. And Gregory, is your microphone working all okay for you?
Can you hear me okay, Grant?
Yeah, we can hear you loud and clear. So I'm just going to go into mute and hand over to you. So take it away.
Okay, thank you. Hi everyone, good afternoon. This is Gregory Campbell, Operations Director of CA Models. Basically, CA Models is one of the largest AM service providers in the UK. We've been in operation since 1983. So as a sort of brief history of the company, we started off as sort of two guys, pattern makers, making models from hand. And then over the years, we've invested in more advanced technology. In 1989, first CNC machine. In 1996, we bought only the second stereolithography or SLA machine in the UK, which was an SLA 3500. And obviously, from the beginning until now, we've got a 36 strong staff with a lot of advanced manufacturing techniques. So obviously we specialise in additive manufacturing in terms of plastic and metal additive. We have 16 systems in total. We also have an open factory with precision CNC machining, 10 advanced systems. We also do vacuum casting, specialist model making, and we have a large paint facility as well, where we do things like painting, lacquering, powder coating, xylem coating, etc. So in terms of the industries that we work for, obviously we have listed on here the sort of main sectors that we do work for, and some of the companies below. I would point out that today, with additive manufacturing being so advanced now, really the industries and the sectors, I mean, it's an open book now. So there will be a lot more than what's on there that is applicable to additive manufacturing. So in terms of the additive manufacturing 3D printing that we have in-house, I'll start off with the SLA technology. Obviously, as I said previously, the first 3D printer we bought was an SLA 3500 machine in 1996, only the second in the UK. Today, we have 10 systems, which are all, they are all latest technology. You can kind of see there that there's a mixture of smaller to medium to large size systems. And I think for us, we like to offer as many different materials as possible to suit the different applications that customers need from this technology. And yeah, the machines themselves are very, very good for printing parts with high feature definition, and in terms of surface finish, the material was very good to work with. I'm going to move on to a case study using this technology, which was for some models, SES satellites. So you can see on the top image, these were sort of full-scale models that were on show, and they've been made in sections using SLA technology. Hand finished, assembled, painted, so that they're obviously as close to the final product as possible. And then below, we've done a couple of handheld SLA models in one piece. On the right-hand side are the SLAs off the machine, and on the left-hand side, they've been painted with a little plaque, and each of the designers of the satellites was given one. So moving on, we also run SLS technology, which is powdered material fused into a solid, and you can see there we've got two systems running. The smaller one, glass-filled nylon and carbon-filled SLS, and the larger system which runs standard polyamide nylon. Now obviously we find with this technology it's a little better suited to small batch production. The machines are obviously got large volumes where you're trying to maximize what you can fit within the volume. So if you're printing 300, 400, 500 up to 1,000 parts, typically you're able to do that in one go, especially in the larger systems, and it's quite advantageous for that. But also with this technology, it's one of the only technologies where you do not have a support structure that is used to hold the parts onto a build platform or similar while printing. So obviously the parts that are printed are held within the powder itself. So here's quite a good example of a sort of mesh structure that you can only really do in SLS, I would say. And what's quite interesting about this sample is you can probably see on the right hand side, year of manufacture. We made this in 2003. So this is actually a 17-year-old print, but when you look at it, it still looks fairly advanced. And I think that's something to think about, that 3D printing and additive manufacturing is kind of all the rage just now, and maybe the last 5 to 10 years it's become a big thing, but it has been going on for a bit longer than that. And then the next technology is FDM. This is something that Stephen Fitzpatrick spoke about a little bit, and similar machine. It's actually the same machine that Stephen was speaking about, but I think those guys have got a slightly newer model than us, but same system, and obviously running production grade materials, ABS, soluble cores, which is the actual support material that you're able to melt away for carbon fiber components, polycarbonate, and Ultim 9085, which again has been discussed in terms of aerospace compliance for cabin components, etc. And a quick case study is just something that's applicable to what we're all going through nowadays. When the lockdown first started back in March/April, as soon as it happened, we were getting inundated with inquiries from the NHS for urgent PPE components, and this was one of the jobs that we did. And basically they just needed visors. They had a design, and the NHS needed visors urgently, and they were looking to anybody who had 3D printing capability to help out. So this is one of the jobs we did. It was a 2-day turnaround, very urgent, as you can imagine, 30 off visors, printed in ABS on our Fortis 900 system, taken off the machine and basically out the door as soon as possible. And that was obviously something that was quite urgent at the time, as you can imagine. And moving on, we're now moving into metal additive technology or metal additive manufacturing. This technology has kind of been CA Model's biggest focus in terms of investment in the last 5 years. You can see that at the moment there's 3 systems noted, but technically speaking, we have 2 systems in-house, and the third system, which is the SLM 500 HL with the quad laser to run titanium at the bottom there. This machine, hopefully, without COVID causing any more problems, will be in the building sooner rather than later. Everything's in place for it to come to Scotland, but the COVID situation is causing some problems there. But ultimately, I'm pretty confident by the beginning of 2021 that system will be in our factory. So obviously, with that being said, we will then be running 3 systems, one with stainless 316, one with aluminium and one with titanium. What I would say is that the 2 SLM 500 machines that we'll have, the one that we currently have, which we've had for 4 years now running aluminium, has been a phenomenal machine. So reliable, and probably one of the best business decisions we made, investing in that machine specifically. It's one of the largest on the market in the UK in terms of the 500mm X-axis that we've got to play with there. So obviously, with the titanium machine as well, it's the same size. We're going to be in a position to manufacture large components, and as those 2 machines are quad laser systems, obviously those 4 lasers are working simultaneously and are able to print parts phenomenally quick. So it's obviously, this has been a big technology for the business in terms of what we're doing now. And moving on, we've got a case study for metal additive manufacturing. So this was a component that we made a couple of years ago now, and using the SLM 500 with aluminium. You can see the part size there, fairly big component. I think at the time it was one of the biggest parts we probably ever made, and you wouldn't have had many components, being made at that size at the time, based on the sort of machines that were available to print parts. Obviously, it combined printing and additive manufacturing in aluminium with post-machining. There was obviously CMM inspection using our in-house Renishaw Revo head, and it was painted. And the actual specification for this job was paint spec to look like Iron Man's helmet, which we found quite funny at the time. But we were, back in 2017, we were actually nominated for an innovation award for this with TCT. We didn't win in the end, but we were quite happy to be nominated nonetheless. And as I say, that was a pretty tricky project, but one that kind of fully shows what the capabilities are for this technology. So obviously, vacuum casting, not to talk too much about this, it's a more traditional manufacturing method. We've been doing it since the early 90s. Obviously, it allows you to make low volume parts quite economically, as opposed to sort of 3D printing. And also, as we're using different polyurethanes, the quality is very close to production grade materials. So we still use it a lot and still run a lot of projects using this. And then moving on to our CNC precision machining, obviously we've got a list of machines here that we have in-house. All of the milling that we have is 5-axis. Largest machine is 2500 by 1800 by 1800 millimeters. So the ability to machine large components. But with the DMG, Mori and the Hernleys, obviously we've got very, very fast precision 5-axis machines there. So we're able to manufacture really complex components fairly quickly. And again, we're typically using our CNC facility for prototypes and sort of low volumes. The Grob 550T is a 5-axis mill turn, and then we've got a couple of lathes and 2 wire eroding machines as well. And a case study for that, it's quite an interesting one. We actually CNC machined a trophy for an MMA tournament in South America. So you can see the image of the trophy. The image above is with our team, a couple of our CNC machinists and our finishing department. So quite a large part, machined in sections in medium density foam, assembled together, finished, and then coated with 18-karat gold. And the image below, that is actually the promotional image that the company who are hosting the MMA event put out in America. So I guess it's quite interesting to think about something that was manufactured in Scotland, 100% manufactured in Scotland, flown over to San Francisco and then down to South America for an MMA tournament. But as I say, majority of it was machined with a couple of 3D printed components on there. And the last sort of case study is combination technologies. So here I'm going to play a model, play a video, sorry, of a model that we manufactured quite a while ago now. And this is basically combining all of the technologies that we have in-house. So all of our additive manufacturing was used, CNC machining. Obviously, you've got high-level assembly, you've got LEDs inside, fully working model, large scale, and from a model making perspective, with us being a model making company, the ability to utilize all of that additive manufacturing technology and precision machining allows you to do some very high-end things with models. And I guess this is a good example of one, which again, as I say, I think this model is about 12 years old, so it's not anything that we've done recently, but it still looks fairly advanced. And it's yeah, it's a good example for people to see utilizing all that technology. I think that's all. I think the Q&A is coming afterwards, but I just wanted to thank everyone for your time, and I believe I'll be passing you back on to Grant.
Yes, thank you very much, Gregor. That was highly informative. And as you correctly pointed out, if we can hold questions for the tech talks until we go into the breakout rooms, that'd be fantastic. But if you are wanting to have some discussion questions in the chat box, feel free. So we're now going to hand over to Andy Simpson from Angus 3D Solutions. So Gregor, if I could kindly ask if you stop sharing your screen just now. That will allow Andy to start sharing his. Andy, can you hear me okay?
Yeah, I can hear you. Can you
Excellent.
hear me?
I can hear you, perfect. So if I could invite you to share your screen and begin your presentation, that would be fantastic. I'll let you know when it's coming through.
Is that coming through?
That is coming through indeed, so I'm going to put myself onto mute and hand over to you.
Well, first of all, thanks very much for the invite. That's very much appreciated. Talk about a little bit about Angus 3D Solutions. Let's see if we can change the slide. Yeah, just a quick overview. It was founded by myself and my wife in 2017. There's just 3 employees, just a small business at the present moment, making it a lot easier for us to manage as well. We're located in the big city of Brechin, which is obviously 40 minutes south of Aberdeen and about the same again north of Dundee. I like to think we're one of the leading additive manufacturing companies in Scotland, and I think we can make that claim with the other people that are presenting today as well, because there's not many of us in Scotland, so it's easy to make that claim. We like to provide prototypes to production solutions, and hence why solutions was been put into the company name. The aim is to try and work with companies and find a solution, not necessarily be us directly, but being able to find that within Scotland so that we can do the manufacturing in Scotland. I'm going to spend a little bit of time talking about a particular technology that we've got here. Gregory's done a great job of explaining some of the other technologies in that in his presentation, so I'm going to just concentrate on one that we offer here, at Angus 3D Solutions. At the moment, we're only one of the companies that can commercially offer this technology, as the other machines are held in universities or companies that are only making parts for themselves. And I think there's a couple of Formula One teams got them as well. We have got an extensive oil and gas manufacturing experience. That's from my own background, and that sort of has an influence on some of the areas we look at as more traditional manufacturing companies, looking at particular reverse engineering as well to try and extend asset life. So looking at using the technology to aid a circular economy, not just looking at new product, but looking at how we can extend old product by using the technology. So why are we in business? Okay, we all know Scotland has an impressive engineering and manufacturing history. And we believe to maintain and further develop this reputation, we must embrace the latest manufacturing technology, and in particular encourage the next generation to look at engineering and manufacturing as their career choice. And that's not just a flippant statement. I genuinely believe that in a previous life working within manufacturing and being responsible of shipping manufacturing overseas, you see how that has an impact on Scotland. And I think it's important that we concentrate on generating interest in engineering and manufacturing in Scotland, the next generation. And I think additive manufacturing has got a place to play in that. Some of the services and what we do here, obviously 3D printing through the Metal X, or its fond name is ADAM, Atomic Diffusion Additive Manufacturing. We'll talk about that shortly. Some of the materials that we're presently offering is Inconel 718, stainless steel, some tool steels, copper, and the earliest in the near future, titanium and 316 stainless steel to follow. But again, just like Gregory, COVID has had a knock-on effect with that, and these have been delayed. We can offer, 718, 316 stainless and aluminium through third parties, and it's people like Gregory as well. That because it's a small network within Scotland, we sometimes rely on each other to help each other out with some technologies and materials. We have got, some internal SLA, multi-jet printing in FDMs, and our SLS is done externally through third party. Offering 3D scanning, which is heavily used in the reverse engineering, particularly looking at having parts that are obsolete, having them reverse engineered, and then using that for additive manufacturing. We offer CT scanning, and that was brought in through a third party purely to help build confidence in additive manufacturing. And that's really what that's there for. Gregory's touched on vacuum casting. We offer that as well. Vacuum forming. We do some carbon fibre, pre-preg manufacturing as well, and obviously traditional machining. So I'm going to talk a little bit just about the Metal X in particular. Okay, so it's got this. When it was first released, it was giving I would like to think it was more a marketing name of ADAM, Atomic Diffusion Additive Manufacturing. The Metal X is essentially an advanced FFM 3D printer. Okay, so you're taking your material powder that is held within some plastic and wax there. As you see, it's about 60% metal powder, 20% plastic and wax. So what we are doing is we are placing that through a hot head and melting that plastic and wax. We're not actually melting the metal powder. And with that, by melting the plastic and wax with the metal powder suspending it, we can then form that shape of the component that we're looking for. So this, by doing that, it helps to eliminate some of the safety risks associated with traditional metal 3D printers, because there's no loose powder, there's no lasers. So there's some advantages of being able to use this technology in existing shops without the big infrastructure to house some of the powder-based 3D printers. And also there's the cost element in there as well. It's far cheaper than some of the more traditional metal printing. But again, it's also reflected in the technology as well. Okay. The process, quite simple and straightforward. Obviously, start with your design. You know, how suitable is it for the 3D printing? You carry out the 3D printing, which is relatively straightforward. It's you know, carried out in a, you know, very much in a traditional looking FFM machine, you know, printer, and nothing special. At this point, what we do then is then once it's printed, we take its weight, we actually weigh it, and then we put it into a wash. And what we're trying to do through the wash there is we're starting to break up some of the wax and plastic in that, in the print. So when it comes out the wash cycle, we re-weigh it, and we're looking for a percentage difference in weight. Once we hit that target, we're now then ready to move it on to the next process, which is the sintering process. The sinter is loaded up, you know, using a argon and an argon mix. It goes through a cycle, which is usually in the region of around about 26 hours. And then component is brought out and it's really ready for use, subject to, you know, any machining that you may want, additional machining that you may require, any coatings, heat treatment, painting, etc. like that. You can basically treat it like any other metal print after that process. So relatively straightforward process. Just some quick photographs on there. One here on the far left shows you some of the parts as they've come out off the printer. They're on a support plate, and they're loaded on a plate ready to go into the sinter. What I maybe should have said there, when we're printing the part, we are printing the part with the material. And we've also got a material that we print in between, which really separates the support material and the actual part. And once that goes into the sinter, that actually turns into a powder, and allows the part to be separated. So for example, what you can see this here is this part is printed off straight out the printer. As you can see here, the support material being printed in in this case 17-4 stainless steel, and the white is the separation between the support material and the actual part. Once it goes through into the sinter, it comes out like this. The powder has turned into the white material is turned into powder, breaks away, allows us to release the support material relatively easy, and you land up with a finished component. What you can't really see from these photographs, but more on this, is an important factor. The finished component and the green part straight off the printer, as you can see in the size there, it's actually around about 19 to 20% smaller. So when we model it into the software, it actually prints the part off about 19-20% larger than the finished component. It's all done by the software, done by fancy calculations to compensate the wall thicknesses and thick areas, etc., so that when it comes through out the sinter process, you're hitting shape. A lot of it, the components that we've been printing off are very much for, you know, prototyping and end use, and reverse engineering is the main ones that we've been using them, where it's very low volume, smaller parts as well, getting used for this in this technology. And again, you know, the parts are, as you know, are one of the main advantages of the system is that we can change over materials in the machine very, very quickly. So it allows us to hop from one material to the next. And in some cases where we've had customers where they've had the same part printed off in several different materials, just to see how the performance of them carried out, etc. And then just a fun part, Angus at the bottom there, Angus RV Highland Q printing off there, but it's not one that you'd be selling for because it's quite a bit of material used to produce that part. Short and sweet. Obviously, questions and that in the breakout rooms later on. Look forward to speaking to you very shortly. Thank you.
Thank you very much, Andy. That was informative, and it's always good to hear about some of the lesser known manufacturing processes. So what we're now going to do is hand over to our final speakers. So Niall and Dickon, I can see your camera on now, guys. Brilliant. So if you want to, yep, we can hear you. If you want to go ahead and share your screen and begin your presentation, that would be absolutely fantastic. Brilliant. That's coming through. So I'll hand over to you guys. Yep. See you and hear you and see your presentation. So over to you guys.
Thanks for taking the time to tune in today. My name's Neil McVeigh. I'm Dickon Walker. We are from a company, AMA Solutions, or AMA 3D, as we're commonly known. We're based just outside Glasgow, and we sort of specialise in the polymer and plastic side of 3D printing, mostly desktop and industrial, but less so the heavy engineering that we see coming out of the NMIS and AFRC. So here's some of the clients that we've worked with. It sort of shows you some of the sectors and the industries, but as has already been said in one of the presentations, the industries and sectors, as additive manufacturing has matured and you've got more materials, especially metallic materials, coming onto market now, these industries are becoming less segregated, and we see an awful lot of overlap between the individual clients.
We'll quickly go through some of the kind of main services that we offer. We try to offer a whole comprehensive range that allow businesses to make the most of additive manufacturing, no matter how long along the journey they may be at the time that we come in. We break up our offering under 4 main headings, and they align fairly well with the various stages, from whether or not you're first thinking about additive manufacturing through to introducing it yourself and eventually using it as a part of your everyday operations. So we'll go through what we do offer, and we think one of the most important things to be aware of essentially is that we can assist you from any stage. So if you have only just, this is the first kind of introduction to 3D printing you've had, or whether or not you use a 3D printing service potentially in the past, we can kind of help you at any part of that with our services, and we'll go into a bit more detail in the following slides.
For us, one of the sort of first things we start off with is just consultancy and design around about 3D printing. An awful lot of our customers, as I said, they come from engineering and manufacturing organisations. That's where our focus tends to be. It's where we see the best applications and the best returns for introducing 3D printing. So our slides have got quite a lot of text on them, so we're just going to skip through the highlights and main points here, and certainly if you have any questions, come and speak to us later on in the breakout rooms.
So basically the first thing that we want to understand is how your organization already works, and that could be through discussions and investigating your existing processes or products. We, pre-COVID, were able to perform on-site evaluations and walkthroughs, basically coming in and identifying where we think 3D printing has the potential to, benefit your company. We've not been able to do that recently, so we've basically been doing everything via either Zoom calls or just via emails and conversations with customers. we basically use our own knowledge of the different additive manufacturing technologies to determine what the best fit might be and suit your specific needs and requirements with, you know, if there's particular mechanical properties or material requirements such as heat resistance or UV resistance, for example, we can kind of help there. And essentially we're on hand to answer any questions and help guide you through the process of investigating additive manufacturing.
One of the sort of first things that often comes up when we're talking to new clients and people who are just looking at introducing 3D printing, they've heard about it, they've maybe had a few pieces produced by an outsourced company. They've worked for them in the past, but they don't have a particular plan or an idea of how it could actually be integrated into their existing processes to augment traditional manufacturing methods, or even just to improve their processes full stop. So one of the things that we tend to focus on is the material information and what's available there, because an awful lot of clients are coming to us saying, yes, we get it made out of XYZ plastic, we get that machined by this company third party, they send the parts to us, we do a bit of Q&A, and if it all looks good, we'll put it in our product. And then you begin to delve deeper into that conversation to see during the design stage, how do they handle this? And it's the same process. They have to outsource the material manufacturer, get it in, do a bit of Q&A, realise it's not quite correct, send it back. And there's a lot of tennis there back and forward. Whereas with 3D printing, especially the desktop side of things, where there's very low barriers to introducing a desktop 3D printer, especially a plastic-based one, into your organisation. And this allows you to speed up that design process, fail quicker, realise you've made a mistake sooner rather than later before you've committed to cooling costs or outsourced massive parts of your production. The other sort of aspects that come slightly later on in the journey is the more advanced things like design for additive manufacturing, as opposed to just producing the part you're used to producing via additive methods. And one of the things that Andy just touched on there, I think, as well, was the sort of testing and evaluation stages, things like CT scanning, X-rays of your own materials to get, again, give people the confidence that the 3D printed and additive manufactured parts have as good properties as the traditional methods, if not sometimes better properties, to be honest. Move on to the next slide.
So this is just something that we wanted to put in because it's something that comes up quite often, where we want to really, put it out there that 3D printing isn't a replacement to your existing tools and processes, and it's really a tool that can enhance your existing capabilities when using it with your existing tools. So if you've got a CNC machine, it's not saying that you're going to get rid of your CNC machine and add a 3D printer. It's saying that you can now 3D print jigs and fixtures for your CNC machine and use your CNC machine really for what it was designed for, which is the kind of high value stuff. So another part of what we offer is design services. So we offer full engineering CAD design for product design and product development, but also specifically for designing for additive manufacturing. So existing parts are often actually designed for injection molding or designed for machining, and rather than just 3D printing that part, you really want to look at how it's designed and then make tweaks or potentially even start again from scratch to design it for additive manufacturing. So we can create models and provide CAD engineering services, and also use our own in-house 3D capture and scanning services, 3D scanning services to reverse engineer parts. And as well as that, we've just added at the bottom there that a lot of the hand-holding and things comes along with project management and any assistance there.
Part of just the design services there, I often see that particularly suited to an organisation that doesn't quite have the in-house either capability or confidence yet. So again, somebody that's early on in their additive journey, they can come to us. We'll take care of the design to begin with. We'll help their design teams learn what the ins and outs of the additive processes are, and then we'll hand that over eventually to the company to be able to take that on internally.
And so the next thing we're looking at is training. We provide training sessions, all from basically from introductory training to 3D printing, right from the very beginning, all the way to more advanced sessions and looking at technical applications and different approaches for additive manufacturing, which come later on in the journey. And we can obviously also offer refresher courses to potentially to companies who have new staff or something like that who need to be brought up to speed with their own additive manufacturing processes.
Quite often, one of the things that we find is that you have people on the factory floor, the engineers and the technicians and things, and they'll maybe actually know more about what 3D printing is capable and what it can do than an awful lot of the management teams and people who essentially hold the purse strings. So we do see that the introductory sessions are actually really good for management and personnel as well, to be able to give them an overview of where 3D printing kind of fits in with their organisation without going into too much technical detail about the actual machines and the materials themselves. Another big part of our business is actually machine sales and servicing, and I think we're one of the very few companies up in Scotland that offer this. So we've been partnered with a few different 3D printer brands. They're all sort of plastic and polymer based as opposed to the metallic side of things. We work very closely with them. One of the main brands we'll go into in the next slide in a minute, Ultimaker, and they again are, to me, one of the greatest systems you can get for a desktop system. It's one of the best ones you can get to introduce as your first 3D printer for an engineering department, for a production lab, or even for the production line nowadays. So the Ultimaker specific ones, I said it's our sort of premier desktop brand. They have quite a few different systems available. They've been going for a number of years now, and they've only just in the last 18 months or so released the next gen systems, which are known as the S5 Pro and the S3 Pro. Both these systems are quite an upgrade from the earlier 3D printers from a couple of years ago. They include material stations, which allow for unattended operation. One of the worst things that happened back in the day was you would start a printer off, doing a long job, a 18-hour print. You would know that you would have to swap the filament halfway through, and then for some reason it would either happen an hour before you expected it to, something like that, and you would miss the changeover and suddenly you would have a failed print. Whereas in Material Station, that takes care of all of that for you. So certainly things have come along quite a way, and the Ultimaker ecosystem to us is really second to none, especially with the Material Alliance and Cura, which is their own in-house software for running their 3D printers, and it works with a number of other brands as well. But the Material Alliance is the main strength, I feel, for this range of products. There are hundreds of companies putting out thousands of materials that you can go on and you can download a live tested profile. So it takes care of all the heat settings, all the feed settings, basically everything to do with your print to be as guaranteed as you can be that you will get a high quality finish and a high quality print.
So we also offer our own in-house print bureau services, which often are quite a good way to introduce your company to 3D printing. So if you're not ready to actually bring a printer in-house, for example, if you do have a part that you're looking to get potentially printed, we can help you with that. Essentially, with any 3D printing that you currently outsource can be outsourced to us, and we have our managed print service that allows us to do low and medium volume, mostly polymer printing, so not so much any of the metal side of things. Having said that, the Ultimaker printers can print in metal, but they do have to, it's relatively similar to the Adam process, whereby it still needs to be sent off and sintered and washed and things.
And unlike the Adam system, that sintering part is not included. So we have a number of in-house technologies that we use here, and for anything that we don't do in-house, if it is something that you came to us for, we have a number of partners that we work with throughout the UK and beyond that sort of cover near enough any material or any type of technology for it.
So we've just put up a list of some commonly used or most commonly used materials that we tend to find ourselves using. So ABS and PLA, common FDM based materials. We also print in composite, so we can use continuous carbon fiber, Kevlar and fiberglass to either provide strength or other material properties, high temperature or
Impact resistance, that sort of thing.
Yeah. There are a lot of newly developed materials coming onto the market now with antimicrobial properties. So there's obviously way bigger, probably way bigger focus on these types of materials nowadays. But we have worked with people in the past who, if you're using a part that's going to be high touch, then ideally you want it to be antimicrobial or antibacterial.
Perfect example would be the visors that, like CA models we were involved with as well for the NHS early on in the pandemic. And that's the sort of one, being able to offer something like that with an antibacterial property built into the plastic is hugely advantageous.
And you'll probably have seen the likes of biocompatible materials being used for implants. Titanium implants and things have been used for decades now. 3D printing has really progressed to the point where people are having 3D printed hip replacements and that kind of thing. And the constant development in the 3D printing materials means that it's kind of limitless in a rapidly growing market.
So yeah, just before we finish up, we're just going to go through just a few examples, show some pictures of what we think of some of the best applications that we've seen and a few items that we've been involved with ourselves. So yeah, looking at 3D printing, you can be using it to try and produce end-use parts, parts that you actually sell to your customer. You can be using it as part of the design process for that, to speed up your design process, get quicker iterations. But one of the highest value applications that we've seen is for process improvement and machines and equipment, sort of close to what Andy was saying earlier on as well about reducing obsolescence of older machines. We see that as being particularly useful for companies like distilleries and breweries and things. We've worked with a few of them that have production lines which are 30, 40, 50 years old, even conveyor systems that are 30, 40, 50 years old, and trying to get spare parts for them is nigh impossible. Certainly you can produce most of these parts with traditional manufacturing methods, but the upfront cost and the capital to get started in something like that is a lot higher than with 3D printing, especially nowadays. Other sort of initiatives are things like your 5S and lean type process improvement initiatives, and you can see down the right hand side there, simple lockout jigs. Something like that is a couple of hours of design and print. You want it and you think about it in the morning, you can have it in the afternoon with 3D printing.
And it's that way that it can be fully customizable, with existing equipment that you might have. So nobody's going to go to the bother of getting an injection mold tool made up to make a few of these parts. But if you have a 3D printer in house, you can create these for yourself.
Last few examples here. Again, some of the advantages of using 3D printing over traditional methods, such as reduced waste. That's a big one. Certainly you can get a lot of waste with support material and things on an FDM type printer. But comparative to a subtractive method where you're removing sometimes 90% of the material from raw material, with 3D printing that's greatly reduced, and you have a little bit more control over how you handle that waste as well. A few other things then, you can see the pictures around the outside. It's for very bespoke jigs and fixtures. Again, things that Dickon was mentioning a minute ago, you wouldn't want to go to the expense of creating a injection mold tool, waiting 12 weeks. The one picking up the chocolate bunny there, that's a suction system with a couple of standard vacuum cups on the end, and to print that out, again, a couple of hours as opposed to weeks potentially waiting on injection mold getting made and then getting your first parts off the process. And even then you may realise they're wrong and have to make a change, whereas with this, a couple of hours later you can have a whole new iteration, a whole new version.
Not to mention the injection tooling cost could be upwards of 10 10 to 15,000 pounds, whereas if you're printing that in-house, you can print it for maybe a few pounds in worth of material cost.
I think that covers everything from our presentation today. So certainly if you do have any questions, please come and speak to us in the breakout room in a minute. And thank you everybody for your time.
Thank you.
Excellent. Thank you much, guys. Thank you. So if you just stop sharing one moment, and I'm just going to put my screen back up. There we are. So I'm just going to pick back up from where we were. So we're going to move to the networking breakout rooms. So this is a function within Zoom that we've practiced offline, and this is going to be our first attempt trying it online. So if you've not done this before, down the bottom tab, you should have a little bar that pops up and gives you some different options, and one there should be breakout rooms. They may not be just visible just yet because I need to open them up. So I'll just walk through a few little things about them before I do that. So depending on what version of Zoom you're using, you may be able to pick the room yourself. So if you can do that, I invite you to do that yourself. If you can't, let us know in the chat. At this point, Stephen and the team will be answering questions, and I'm going to be in the background moving people about at your request. A limitation we've discovered is that if you try to leave one room and move into another, Zoom may just automatically disconnect you. So apologies if that does happen. You haven't been kicked out because of anything you've done. As I say, it's just a limitation with the software. So what I'd ask you to do is select the room that you definitely want to go to. But what I would say is if you do have your question answered or you found out what you're wanting to know about, then you can migrate to a different room and you can try it. But if you do just get disconnected, apologies.